Hey everybody, it's Mr. Carr again. Today we're going to start off with 9.1 day 1. We're going to start learning about the circles. There's lots to do with these. So we're going to take some basic facts today and looking at some vocab. All right, so here's a lot of vocab to start. First thing is, what is a circle? Okay, I'm sure ever since you were younger, you would be able to identify what a circle is. Okay, probably I don't have any issues with that. But we're going to look at an actual geometric definition then. Okay, so a circle is the set of all points that are equidistant from a given point called the center of the circle. Okay, so that looks like this. Here's my center. All of those points, like if I try to make a circle with like just a tiny little points going all the way around, they're all the same distance there. So it doesn't matter where I go. Okay, if I look at any of these lines, those all have the same distance. And that distance is a special name. It's called the radius. That is the distance from the center of a circle to any point on the circle. So here's my circle, here's my center. Any point there is going to be my radius. Okay, and again, it doesn't matter where I go, so the radius is still the same length wherever it's at. Okay, the diameter is the distance across a circle through its center. So that's a special line that goes, here's my center, from one end of the circle to the other and passing through the center like that. That's my diameter. One thing to point out is that it's made up of two radii, or radiuses, whatever works. So I could say that diameter is equal to 2 times the radius. Okay, circumference, that is the distance around a circle. Okay, so this is distance here. So if I draw my circle, and let's say you started here and walk in a circle around. Okay, how far did you walk? That's what we're talking about for circumference. Central angle, an angle whose vertex is at the center of the circle. So remember with vertex, that is the point where like the two rays meet. So if I do this, here's my center, and I draw in 2 radii. That's what creates my central angle like that. Okay, so that's my central angle. Arc measure is the angle that the arc makes at the center of a circle. Okay, so it's kind of related to the previous problem, but if I look at this, here's my center there. My arc is referring to this degree measure. Okay, it's actually the same. That's one of our things we'll talk about in a minute here, but this is what we mean by that. Okay, so it's degrees. Hello, hold on one second. There we go. Okay, this is the degree measure here of our circle. Okay, minor arc. There's a part of a circle that measures less than 180 degrees compared to the major arc, which measures between 180 and 360. Okay, so when we talk about that, we're going to name them with points. So for example, let's say I have right here, got A, B, and C. Okay, so let's say I want to look at these two right here, that minor arc. That is going to be arc AB. I name it with 2 points. Okay, so we name a minor arc, we use 2 points. So if I say AB, I'm always talking about the shortest path between A and B. I'm not referring to this. That is my major arc. Okay, so if I want the major arc here, I need 3 letters. Okay, or I should say 3 points. So if I want to do the major arc there, I would actually label it as ACB, because that's the path it would take. It would go from A to C to B. Okay, so anytime I use 2 points, you're looking at what's the shortest path between those 2 points. If I'm looking at 3 points, now I'm probably going to be going, I'm looking at the major arc at that point. All right, last term for here is our semicircle. And that is when I have an arc with endpoints that are at the endpoints of a diameter of a circle. That's awkward, with endpoints that are at the endpoints of a diameter. Yeah, no, I guess it makes sense. Okay, that measures 180 degrees. So looks like I'll put a little circle here, just referring to this. If that's my diameter, then if I say that right there, that is a degree measure of 180 degrees. Okay, so that's what we're referring to. Some of the other things here that's going to come up mostly for tomorrow, but there's a difference between arcs and arc length. Okay, if I talk about the measure, okay, so this is the measure. That's talking about a degree measure. It's less than the 180. The major arc is, again, a measure there. Here, this is an arc length. It's actually going to be a distance. This is going to be for the next lesson. Okay, something to be aware of for that. All right, the measure of the entire circle. Hopefully we remembered that from our days and other math classes before this, but circles are 360 degrees. The measure of the major arc is the difference between 360 and the measure of the related minor arc. So that's a neat little feature of that. When you look at this one right here, whatever this minor arc is, let's pretend that looks like, let's say it's 80 degrees there. Okay, that would mean the major arc going the rest of the way is 360 minus 80, which is going to give me 280 degrees. Okay, so that's always going to be the case there. And anytime we're dealing with a semicircle, it's going to be 180 degrees automatically, which again passes through the diameter, or sorry, it's made by a diameter. So if you know you have a diameter that passes through the center like that, you know that that's going to be 180 degrees. Or if I go the other way, also 180 degrees. Real quick naming purposes, in this scenario here, if you want this one, that specifically, then you would say arc like ACB, something like that. Okay, but if I don't have the third point, if I just say AB, that's fine, because it's still talking about 180 degree measure. Okay, so just be aware of that for naming purposes. All right, arc addition postulate. The measure of an arc formed by two adjacent arcs is the sum of the measure of the two arcs. This diagram doesn't really help as much. It also doesn't talk about, well, I didn't mention it earlier, but one thing to mention, that's really frustrating, it's not on there. Okay, one thing to mention is that central angles always equal the arc measures. Okay, so like when I look back up here, remember my central angle was right here. Okay, it's an angle whose vertex is at the center. So anytime I have this kind of a scenario, the degree measure of that angle and the degree measure of the arc are the same. Okay, so that's what we're looking at in some of these cases. When we do arc addition postulate, if we put two angles together or two arcs together, then their total is going to be the sum of them. So for example, let's say I do this one here, and I call that 80 degrees. We'll call that point E. So if I were asked the measure of arc ABE, or actually I just say AE, that is going to equal to 50 plus 80, which is equal to 130 degrees. And that's it for that part. We can just add those together is the idea, as long as they're adjacent to each other. So they're adjacent because of BC like that. So that's what we're going to look at here. And remember, every one of these degree measures, even though they were kind of referring to the central angle, it's also going to match up to the arcs. So that's a 140 degree arc. That's a 55 degree arc, okay? So if I want to find the measure of BD, BD is going to be the shortest distance from here to here, okay? I use two letters. You look at the second one, that's BCD, which is going to go the other way around. Okay, so if I look at BD, let's do that in let's do blue. BD travels this path. That's going to be 55 plus 105. So 160 degrees. Okay, BCD starts here and goes this way. So it's made up of 140 and 60. So 140 plus 60 gives me 200 degrees. Another option, don't forget, that's the major arc there. So I could have just done this, 360 minus the 160 that I found over here, and that also gives me 200 degrees. Doesn't matter which way you do it. It's just whatever makes sense to you. All right, I mentioned circumference. Let's talk about how we can calculate that. Circumference of a circle. There's two ways of doing it, but they're really the same thing. Okay, it is 2 times pi times radius, or pi times diameter. Or the reason they're the same is that if I take 2 times the radius, that is a diameter. So those are the same things there. It just matters, like the only thing that matters is what information do I give you. So in this case, I give you radius, and I'm asking for radius here. Okay, for both of these, I'm going to use this version. If I gave you the diameter, then you could use this one. Okay, so just make that aware for yourself. All right, so for example 2a, find the indicated measure. Find the circumference of a circle with a radius of 11. So it's going to be 2 times pi times 11. Okay, I do that. My circumference is going to come out to, let's say, 69.12. And this was meters, so it's going to stay meters. Remember, circumference is a distance. Okay, so we're still dealing with meters here. We're like, dealing in meters or feet or inches or whatever it is. Okay, that's a distance. Part B, find the radius. So I want to work backwards. If I know that circumference is 2 pi r, one thing that might be helpful is if I can solve this for the radius. I do that by dividing both sides by 2 pi. So I can have a new formula here for myself. Radius is going to be the same as the circumference divided by 2 times pi. So in this scenario, if the circumference is 18, that means my radius is going to equal to 18 divided by 2 pi. This is a very easy problem to make mistakes in a calculator. So make sure that you are either doing it in a fraction like this, or make your calculator look like this: 18 divided by parentheses 2 pi. Okay, it needs to look like that. All right, if you don't do that, so for example, if you do over here, 18 divided by 2 pi, what that's really doing is this: it's taking 18 divided by 2 and then multiplying by pi. That's not the right answer. We need to have 2 pi all the way underneath. So that's what it looks like there. So don't do that one. In fact, I'm just going to get rid of that now because I don't even want you to see that as an example. All right, it needs to look like this or this. You do that and you get a radius of 2.86 yards. Okay, last thing for today, and that is area of a circle. Area formula is pi times the radius squared. Okay, this one we do change the dimensions. So remember earlier I said for circumference, okay, this is in terms of meters and yards. When I do area, now the answers are going to be, let me put this here. Dimensions are going to be square blank. Okay, yards, meters, inches, whatever it is. It's going to be square that. All right, it represents a slightly different thing. So let's look down here. So we've got our last two examples. Area of the face of the watch. The radius is 4.2. So if I know that area is equal to pi times radius squared, so I'm going to do pi times 4.2 squared. That one's pretty straightforward. You just plug it in your calculator just like that. Make sure you are doing the squaring first. So if you're doing it like multiple steps, do 4.2 times 4.2, then times pi. You do that and you get 55.42 square centimeters. Okay, and there's that square centimeters idea. Square, like that's representing an area. It's taking up a certain amount of space that's on a surface is the idea. B, find the diameter. So I'm going to work this one backwards. All right, so I'm going to start with the formula. I'm going to rewrite a new version so I can get to R. Okay, so I'm going to divide both sides by pi, so that A divided by pi is equal to R squared. And if you think back to our Pythagorean theorem, how do I get rid of a square like that? Well, I can take the square root. So when I do that, I'm going to say that the radius is equal to the square root of area divided by pi. Okay, so that means I can do radius is equal to the square root of 201 divided by pi. And that is going to equal to, I believe it's like 7.99. And that will be, in this case, centimeters. okay? There's a 9, a little bit higher actually. But I want diameter here. So if you remember diameter, that is 2 times the radius. So diameter is going to be 2 times the 7.99 something. Let me find out here for a second here. 7.99, well, technically 999. Okay, I do that. I multiply that by 2. And I get to 15.997 or 998. And that's going to be centimeters in this case because we worked it backwards. All right, remember, area is going to be squared for the dimensions. Radius, diameter, circumference, those are all just normal. They're just regular single dimensions. All right, that's it for today. We got a few you try now problems. Give those a shot. Talk to you about this a little bit later. We'll continue our circle work going into, arc length and sector area. That'll be for the next lesson. All right, take care, everybody.